our notebooks, because we're going to work some in sample problems.
So is the test, the review, and the assignment all do something like that? Or?
Well, yes, they are. What we're going to start out with is stuff from the review to help us with the test, because in lesson 18 we have a few things that we're going to be going through on the review that we didn't spend a lot of time on in the class. So I'm going to get those up now, and then if you work on them here, I think you will be in good shape when we get to the actual class. So let's look at this one right here and see if you can, I'll make it a little bit bigger. I'm showing you the answer at the same time so that you can check your work. But why don't you go through this first one and see if you can do it. Is there anybody that needs help on how to set this one up? Go for it then. See how you do. We're if you need help on how to set that one up, you're supposed to let me know.
Okay, thank you.
Otherwise, you can look across the table that way. Kate did it. What I did is I made a tic-tac-toe that was 3 wide rather than 2 wide, 1 more wide. Nope. There you go. Now do the crossers. So here I would write what is that, 4x? Got it? Okay, now you go. Sam, you okay?
Yeah.
Connor, you got it? Anybody need more time? Lauren, you good? Okay, but you know what you're doing. Lex, you good? Eric, you okay?
Yep, I got it.
I'll switch screens to show you how I set it up and how I did it. Now, I didn't get the last, I didn't put in the last step here, but I should have. Everybody ready? Or just still need some more time? Okay. So, questions on that one? Next one. Now it says multiply. What it really should say is calculate. That might be a better way to say it. I think the only thing that you could possibly do wrong is if you would have not pressed the over button when you got to this step right here, because otherwise you would have said 6 to the 3 plus. That would have stayed as the exponent. Questions on that one? All right. Kate, is that an iPhone?
Yeah.
Okay. And nobody still has found a free graphing calculator. Next. Discuss this one with the person sitting next to you so you understand what they're saying. Are the people at your table?
X by saying X.
You see something about 5.
So help us out, Madeline. Are we paying attention to the numerator or the denominator?
The numerator?
That would be one of the choices.
Well, wouldn't you just like...
It's not the numerator that's going to be problematic. Do you remember the cars in Portland during the ice storm? They were sliding down the hill. That's because the denominator was 0. There was no friction. Okay? That causes problems. So we're paying attention to the denominator. The denominator, what did you say, Kate? Can't? Or who had it? Sam. The denominator
Can't be 0.
Can't be 0. X minus 5 is 0. What number, take away 5, gives you 0, Lauren?
Sorry, what?
Yeah, that's okay. It's Tuesday. Although, hold it. Thought it was Monday. I gave you guys Mondays off, but Tuesdays you got to start like being with me, people. Okay. The denominator, so x minus 5 is 0. So I'm thinking of a number. I take 5 away from it. I get 0.
5?
5. So x cannot be 5. Everybody okay? Were you? Yeah.
Yeah, we just did it a different way. We just did like the x squared divided by x, so 25.
Ooh. What we call that is serendipity. When you make 2 mistakes that kind of cancel each other out and make it so that your math works out right. Yeah, that is going way down the wrong path.
Awesome.
Nice.
Okay, but does it make sense the way I explained it now? We only pay attention to the denominator. And we know the rule that says the denominator
Can never be 0.
can never be 0. It doesn't matter what the numerator is. No. If you get stuck on this one, I would strongly urge you to take a trip down Desmos Lane and graph that thing. So if we look here on lesson 18, where'd it go? FMR 18. Come on, 1 through 4. RF1, 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 FMR 12 through 14, FMR 8 through 11. Well, I guess we don't have one. We'll make our own. FMR 18. Okay, so if we make that equation, f of x equals a fraction x to the second minus 25 over x minus 5. Okay? Now, on this, it looks like it's a line. And the reason it looks like it's a line is that you can cancel x minus 5, but you have to factor the numerator. X squared minus 25 is two factors. Eric, what are they?
But wait, what?
What are the two factors of the numerator?
5.
X minus 5.
X minus 5, x plus 5.
X plus 5, right? X minus 5, x plus 5. So the x minus 5s cancel out. So it looks like it's a line. But if you scroll along here, that one is 0. That one is 0. But if we go to over 5 and we get right on 5, we'll see 5 comma undefined. In other words, there's a hole in our line. That's what we call it when we get into college algebra. There's a hole in the line. And the way you discover that hole is you graph those two functions. G of x equals x squared minus 25. And h of x equals x minus 5. And you notice that those two come into a location right there where they are equal to each other, which causes them to factor each other out. So you would not discover this unless you strolled along there and saw that one point where it doesn't make sense. And I can tell you this. How many times in my schooling did I make that mistake? Probably about 10 to 15 times I would say this is the answer, when in fact that particular number doesn't work at all. Okay, you plug it into the equation, you find out, hey, there is no answer for that question. All right, next one. Oops, I have to do some more work there. Next, done. Okay, next one. It might be too big. Okay. Graph the equation and see which one of these it is. So what are you going to do? Take out your graphing device and do it. Okay? All of you have at least one graphing device. You don't have a graphing calculator, you got the phone. Madeline, are you going to do it on your phone or on the graphing calculator? You know how to do it? Mm-hmm. Oh, okay, because otherwise I was going to show you. Anybody need me to show you how to do it on a graphing calculator? I'm going to zoom in on the right answer here.
Actually, I need your help.
Okay.
I could do it, and I was like, nope. Basically, every time.
Okay, so we click the on button. Click the plot function y equals
Wait, where's the plot button?
the right here.
Oh, okay.
Y equals, and we're going to type I forgot what it was. 1/4 x, 1/4 to the x, right? So I'm going to just write 0.25. Are you good with that?
Yeah.
To the x, and then your x button is this one right here.
Okay.
And now when you graph it, it's possible I gotta clear my tables. I forget how to do that because I don't use this often enough. Second function stat. I have to turn off my stat plots. All of them are off, so I don't know why it didn't graph it. Should have. Did yours?
No.
Yours didn't either? Some of you good with the graphing calculator? I suck at them. Don't use them enough. Okay. What kind of... Oh, I should try Zoom Fit and see if it...
Oh, I got mine to work.
What did you do?
I didn't press the graph button, so that's probably why.
Oh, there mine is. You can see it way over here. So I should do zoom window and maybe do how big is it on
Mine has like a full.
on here? It goes from 5 to -5. So I'm gonna zoom box and go from zero. Let's not do it that way. Let's zoom in, see if that'll do it. Zoom in, zoom, integer. We tried Zoom Fit, didn't we?
You try Zoom 9?
Zoom 9? Nah, that didn't do it. Oh, you can't see it. Window. X goes from -5 to 5. Y goes from -5 to 5. Now when we do graph, it'll look like the one in the book.
You just said 5 for like the X and the X.
I did -5 to +5 because I wanted it to look like the one that's on our question. Okay? Now, to me, that graphing calculator business is way tougher than Desmos. Because Desmos, it comes up automatically. I don't know. It just seems a lot easier in Desmos. Did you get yours to graph okay? You are a professional at using the Inspire calculator. You are inspired by Inspire. So it works for you, huh? Questions? All right, let's go on. Remember, I've given you a whole bunch of ways to do this. Quadratic formula, Desmos, me. Graphing calculator, which function? Polysimul 2. Okay, one of those is going to work. If you've got the Inspire, you can go to, let me think. Math. No, clear. It's not that. It's yours is an 84 plus C. Sorry. Somebody had an Inspire here. Was that you, Eric? No. Who's got maybe it's the other class that somebody's got it inspired. You know how to do it on yours?
No, I usually use Desmos for it.
Okay, well, let's try it on yours. What you would do is go to Apps, and PolySimul 2 is number 8, enter. And then Poly Root Finder, enter. And now, yep, enter. And then go to next. And the first number is 5. Just put a 5 in. Enter. The next, yeah, it's minus.
You do the equation.
See that? I'm right here. Minus. What happened? 36 minus
If you do the equation, you just
32
set equal to 0, and then the
equals
two
0.
lines that show up are the ones that. Yeah, in the little point, and it'll show you that it's negative.
So when you're on that PolySimul thing, do you go to like the root finder?
Yes, I'm sorry. I thought you already knew how to do this one.
Yeah, I kind of did, but then.
Okay, so polyfind. Yep, and then next. So you got yep. There you go. Now just put in the numbers 5, negative 36. So this is kind of like the quadratic formula for people that don't want to go through all the button pressing in the quadratic formula. You only have to press 3 numbers, and it'll tell you what the. It uses something like the quadratic formula. The difference is it can find you roots for to the 3rd power. How many is the maximum number of roots that you can have if it's to the 3rd power? If there's 2 to the 2nd power, 3 to the 3rd power. If it's to the 7th power, you could have 7 different roots. Did everybody get these? Negative 4/5 and 8. I see some people did Desmos. Not a bad way to fly. So we would do f of x equals, what were the numbers? 5? X to the 2nd minus 36x minus 32. And if you notice, all you need to do is to just click on the roots.
They allow negative 0.8 or redo.
I was wondering that. Let's see what how the question is phrased to see what it says, what it would allow. Type an integer or simplified fraction. So on the test, if you put negative 0.8, it will mark it wrong, and I'll give you credit for it. Because I can do that in my head. But they want you to write negative 4/5. Questions? Now, one of the things that screws people up is some people think this is a ordered pair. What about the way they wrote it shows you it's not an ordered pair?
Is it the parentheses?
Yeah, it's not in parentheses, it's in brackets. What are the ones that are squared called? Brr. People wear them on their teeth. Brr. Braces. That's the 3rd kind of thing that they can do there. Questions? Number 17. This is a kind of a hard one because we never talked about this concept. And so I don't think you will automatically figure it out. So let's do this one on paper, and I'll show you how it's done. 5 square root 5 minus 2 square root 45 plus 7 square root 125. So those are our numbers that we're going to start with. Now, let's pretend that this is 3 poker players. All right? These are pairs, and these are singles. So would you agree this guy has a pair of 5s and a 5 left over? Okay? Can we rewrite this as a pair with something left over? 45, the square root of 45. Well, what can we break 45 into?
9 and 5.
9 and 5, and 9 is a pair of 3s, right? So you have a pair of 3s on your hand that you didn't count yet. So let's count that pair of 3s. So this is the square root of 9 and the square root of 5. But the square root of 9 is 3, but we already have a 2 there, so how are we going to rewrite this?
Don't you multiply?
Yes, you do. So that's negative 6 square root 5. I'm gonna pause and you talk it over with the folks at your table just to make sure you understand that. Go.
Yeah.
Don't just not convince these other two.
I'm just looking at what you did.
I'm just trying to put it in my head.
Could you just plug it into your computer?
If you plugged it into your calculator, there's only certain kinds of calculators that will give you the right answer. Because if I press on my calculator quit, 2 times square root 45, it will give me not a square root. And our directions say integer and a square root. Now, does the CE do it as a integer and a square root?
Mine does.
Yours does? Yeah, I'm gonna show them your Casio because this is a which one is this? The 115? No, it's the 300. The 300 isn't the best one, but if you notice what's neat about her calculator is it knows how to play poker with these numbers, and so it gives 34 root 5. I am 34 root 5 years old doesn't make sense, so sometimes we have to make that into a decimal, and so if you press the S to D key, that's the exact same thing that,
That's kind of nice.
there's something. Oh, I see. You did the whole thing. I only did the second term. Everybody okay? Yeah, this is kind of a nice calculator to have for things like that. Does anybody know how to do that on the graphing calculator? Because it seems like it should be able to do that, but it doesn't. I wonder if we did that in Desmos, what we would get. Let's try it. So if we did 5 square root 5 minus 2 square root 45. It doesn't look like it's going to do it, does it? Plus 7 square root 125. Nope. It does not do it for us. Next one, or let's finish this problem then. So let's talk about this guy's hand. Square root 125 is the square root of 5 times the square root of 25, right? What's it? How many? Can you get any pairs out of that? This is a pair of 5s, right? Square root of 25 is 5. Times 7 is 35. So now you have 5 square roots of 5. Minus 6 square roots of 5 is how many? Negative 1 square root of 5. Plus 35 square roots of 5 is 34 square roots of 5. How important is that? Good question. I can tell you this, math teachers think it's important. I can't think of a problem in which, oh no, Kevin, you can't just give the approximation, you need to give the exact answer. Can't think of a situation like that in real life, where the referee gets out the chain and says, you are 34 square roots of 5 short of a first down. No, I don't think so. Okay. Last one. This is kind of difficult, and so we're going to do this one together too. We need to know how to do this when we get to college algebra. And actually, we don't ever do one like this because we only do to the first power. But let's assume that let's see how we do this. When you do long division, only pay attention to the first number. So on this first step, we are only going to pay attention to this and this. What do we have to do to x squared to get 4x cubed? Multiply by 4x. So we put the 4x up here. When we multiply 4x times x squared, we get 4x cubed. We also have to multiply it by -3, and we get -12x squared. Now remember, we're subtracting. Okay? So if you have 4x cubed and you take 4x cubed away, what do you have left? Nothing. So let's X that part out. What do you get when you take -x squared minus -12? Nope. -x squared minus -12 plus 11x squared. Okay? Because remember, here's what you're thinking. -x squared minus -12x squared. This is the same as plus 12x squared, right? And you get 11x squared. Okay? Remember, we only pay attention to the first term. So what are we going to have to do to x squared to get 11x squared? Multiply by 11. If we take x squared times 11, we get 11x squared minus 33x. Correct? Because this times this is 11x squared. This times this is -33x. You with me? Okay. Now when we subtract, remember we're subtracting, we get, well, these two are going to cancel each other out. If you notice, there are no x's here. There is a +8 at the end. So our answer is -33x plus 8. We can't divide this anymore. So we would write this as remainder -33x plus 8. The way the another way to write that answer is the way they did in our book. Ooh, simplify your answer. Did I make a mistake? Because they have 4, negative 11. Oops, this is supposed to be plus 33. So I'd made that mistake because we're subtracting negative 33. But I don't see where they got the 12x plus 5. What did I do wrong? Nope, don't see it. Not going to say they're wrong. I'm just going to say I'm not wrong. I'm not going to say they're wrong. I just don't know where I made a mistake. Find my mistake and we'll all be happy. Now, the problem is if you tried to do this in Desmos, I don't believe Desmos would be a lot of help. But what you can do is, let me think if I can find that. There's an app out there. Let's see, faculty from Carlson. Where is that darn thing? I thought it was from her. Okay, there's an app. Anybody know the name of it where you can take a picture of a problem with your phone?
My Math Lab.
My Math Lab?
Yep.
It can't be My Math Lab because that's what our...
Or, no, what is that?
Mathway?
Mathway, yeah.
.com?
That mixed up.
I don't think that's it. Let's do a search. App that solves problems by taking a picture. There we go. It's called Photomath. So on your phone, download Photomath. Do you really? Why didn't you just say it? What it was. Unbelievable. I mean, help us out, sister. Don't make us whistle in the wind for nothing. What was it again? Photomath?
The first one, yeah, it worked too.
Mathway would have worked.
Yeah, it works good.
But I don't. Do they have a?
Give me the same answer for the last one that you missed up
Got
on.
me the last 5 answers on the screen.
Did it really?
Yeah.
Good. Well, why didn't you tell us? Oh, you did tell us about Mathway.
He said it wasn't there.
No, that's because I couldn't get it to work. So I'm going to go back to the problem. So did you write it down, or did you take a picture of my screen?
I just did this.
Typed it in my phone.
Oh, you typed it in.
Divide the-
Oh, okay. Yeah, I see what you're saying. But here I'm going to show you. So on this problem, oops. Let's go. Come on. Skip. I just want to go to the spots. Plow. Okay. Whoa. So on this problem, I've got my camera. I'm going to take a picture of the problem. The problem for me is I can't hold stuff steady worth a darn. Okay, so now it's got the problem. And how do I get it to work now? Calculate? There we go. Now what? Equals? What do I do? You're the one that says you know how to use this thing. This is the first time I've ever used it. Come on, sister.
I can't take it seriously.
What's that?
No, wait, just. Well,
4x.
Divide?
oh, it's focusing in now, so I can't really help you there. Okay.
We can't calculate the incomplete math problem. Why can't you calculate? Oops. Undo. Anyway, I don't know. Somebody know how to use this photo math? You can go for it and get her done. But you said that you typed it into Mathway, and it got it, and that's what you use too, is Mathway. Okay, that's. I had a student that used Mathway last semester, and she liked it a lot. But it couldn't do like graphs like Desmos can. Pardon?
I use Desmos.
Okay. Questions?
I have a different app, that's why.
You what?
This one has the go button on it, so
Oh, do you have an?
I have a different app.
What app do you have?
It's called.
So you can take a picture of it too?
I'm not sure. I just always type it in.
Oh, so you type it in.
Just because, like, if you take a picture, sometimes it doesn't read it right. You're gonna
Oh,
always
okay, and then you got to do it over again.
Mhm.
I'm gonna show you the video from Photomath because I think it's kind of cool. Let's see, Photomath video. Let's try that. Here we go. Yeah. Now what is she flipping? So it just is doing it on its own? I did not get it. But I don't know that I had it set. In my mind, the only reason it's cheating is because you're asking a question that should not be asked on an algebra. If a computer program can figure it out, you don't need a person to figure it out. We should be here for figuring out math problems. And so I am asking this question right here on our assignment because the book or the course has a competency that you'll be able to do long division. Okay? That's why I'm asking the question. It does have its uses. All right, let's stop there. Oops, I got to stop it. The thing I don't like about YouTube is that it keeps on playing stuff even after you're done using it. You have to actually close the darn thing down so that it will quit. So Mathway, you like that? Not a bad app, apparently. Okay, and then the other one that you said, Maddie?
It was like Simolab.
SY is how it started. I'm not sure what.
SYMBOLAB.
Simolab or something. I'm not sure.
Something weird like that, yeah.
Okay. Page 139 in our books. Last time we did 5 years at 2%. Do you remember how we did the math? We took $1,000. I think Was it $1,000 we started with, or $100? $1,000, right? $1,000 times 1.02 to the fifth, right? Number one, we're going to revise our formula that we did last time, and we're going to have 50,000 at 2.5% for, and here's where the fun stuff comes in, 20 years, 50 years, 100 years. So these tables here are going to do for 20 years. These tables here are going to do for 50 years. And these tables here are going to do for 100 years. The only hint I will give you is do not put 0.025 to the whatever power it is. The answer will not be found by taking 0.025 to that power. We're on, Wes, we're on page 139.
What's the equation?
Oh, do we need some help with the equation from yesterday? Let's get that equation from yesterday.
That was like a whole 24
The-
hours ago.
Yeah, it was. And if you recall, yesterday was the Maddie rest day. Remember that?
Yeah.
Okay.
I recall.
So the maturity value is what they call for the formula, is the principal times 1 plus the interest rate to the time. So let's fill in the numbers. What's this number? Yeah, what's the number though?
50,000.
Got it. When you get done simplifying, what does this become? Uh-oh.
0.025.
1.025 in this case. Yesterday's was 1.02 to the, and then each one of your tables has we have three different times. Anybody have an answer? Any group?
First one.
What do you got?
The first one, $81,930.82.
$81,930.
$30.82.
This is what you
I could be wrong.
I could be wrong, he says. So take that answer to the bank. Felicia.
Yeah. 590,685.81.
Your answer should be between those two, if that helps you any.
Yeah, I have that.
It's a big door, so it shouldn't be too hard.
I got $171,855.
Just wait, $171,800
And $55. And are we rounding to near cents?
near cent.
44 cents.
Wes or Eric?
Looks good.
Looks good, Eric says. Quality control. Hey, our own quality control. Nicole, why do these three answers make sense?
As the number gets bigger, they
Would you accept a bank that if you put it in for 10 years, you get a certain amount, but then if you put it in for 20 years, you get less money than that? No, that would be the wrong bank-to-bank act. Questions? Oh, we didn't put down the calculation, right? It was 50,000 times 1.025 to the 20 times 1.025 to the 50 and times 1.025 to the 100. Questions? All right. Is your formula linear? Well, there's a couple ways to figure it out. One of them is to take your formula and graph it. Let's add a graph here, and let's say f of x equals 50,000 times 1.0225 to the x. And when we graph it, we should probably make our x go from 0 to 100, because that's how many, not 1,000 years, 100 years. And our y has to go at least from 50,000. Well, we could start at 0, I guess. That wouldn't be so bad. But it has to go all the way up to, well, let's try $1 million. And if we put in $1 million, we get a graph like that. Okay? And then if we go along, we would find that at 20 years, it's $81,930.82. At 50 years, it's $171,000. And at 100 years, we can't. It'd move over a little bit. At 100 years, it's $590,685. The other way that you could do it is you could add a table, and this value would be 50,000 times 1.025 to the x. I forget what our variable was called. X1. X sub 1. And so, at 0 years, of course, you should have just 50,000. At 20 years, you would have 81,000. At 50 years, you'd have 171. And at 100 years, you'd have 590. Questions? Make sense? We'll take our break. When we come back, it'll be 9 o'clock. 10 o'clock. Or 9 o'clock. One of those two. It'll be a certain time.
We really don't want to do like of her. Yeah, we put hot water on it. When she I poured hot water on it. Yeah, we really don't want a tattoo this.
Usually pretty good. It's just ever.
Yeah. You're all over the messy. I have a lot to do with it. So mine, it hurt just to like mark everything. Just like right there. So like, I was trying to go against it. Oh, it's hard. It's like literally just like sitting right there. So like, and it's like on my arm. Like I don't want to rub against it. It's like I was sitting there for hours.
So, oops, we gotta wait for Wes. Oh, I'll take attendance while we're waiting. Forgot to do it yesterday, so check to make sure that I have it right for you for yesterday. Brittany's gone, Alicia's gone, Gavin's here, Alexis is here, Janae is gone, Felicia's here, Nicole's here, Max is gone. Brandon's here, Eric's here, Caitlin's here, Rachel's gone. Keegan's gone. Grace is gone. Riley's gone. Wes is here. Connor's here. Paige is gone. Jocelyn's gone. Eric's here. Madeline's here. Bailey's here. Dylan's gone. Julie's gone. Savannah's here. Savannah, were you? Yeah, you were here yesterday.
Yeah.
Lauren's here. Jacob's gone. Desmond's here. You were not here yesterday, right?
No.
And Sam's here. Well, we'll wait for Wes to get back.
Yes, we love it.
Okay, let's just get started. In your book, it says the Nashua Telegraph reported a case in 1981 in which a man found a $100 bond that had been accruing interest at 10% for 110 years. So I looked up the article here and I posted it on our screen. And it says, the way George Foster figures it, McDonald County owes him $3.5 million, most of it interest, for the 1871 bond. So since it was 1871 and now it's 1981, that'd be 110 years, right? So it's going to be to the 110th. Foster told the county court he stumbled upon the $100 bond 2 weeks ago on a shelf in his Ginger Blue Lodge resort. If the bond proves authentic, the 10% annual interest could make it worth $3.5 million. What's the math that you would press in your calculator to get that? Ooh, you can't see that. What's the math? It's a $100 bond, right? Times 1.1, because that's 10%, to the 110 years. And that's where he gets the $3.5 million. The county refused attempts to cash the bond for $110 in 1874, 1875, and 1876 because it didn't have enough money. Today, McDonald County, about 200 miles south of Kansas City, is still having financial problems. It's a month behind in paying its bills. The practical solution is that we don't have $3.5 million, so we'd have to refuse payment, he said. He added that Foster would then have the option of suing the county. I don't know exactly what we're going to do, said Foster when asked if he would pursue the matter. I'm not going to spend any great sums to collect an uncollectible debt. I'm having lots of fun. Kind of interesting. Seems like a legitimate claim. I guess the part that I'm confused by is how they know they wouldn't pay the bill in 1874, 1875, and 1876. I don't quite understand how. I mean, do you think their records are that accurate that you'd be able to go back in the record books that long ago, 100 years? I don't know. It's interesting stuff. Page. Or am I the only one that thinks it's interesting stuff? 19A. Suppose you invest a $1,000 principal in a 2-year CD with an annual percentage rate of 6%, where the compounding occurs monthly. Now you got a problem, right? Because our interest rate is listed as annually, and we've always been doing annually up to this point. Now we're going to change it to monthly. So let's start out with as though it would be a problem like the ones that we've been doing. So is this B or A? 19A. So the amount, M, would have been $1,000 times 1.06 to the second, right? That's if it's compounded yearly. Does everybody agree that if we're going to compound monthly, we have to change this number and we have to change this number? See if you can figure out at your table what those two numbers would be. Go. I'll give you a hint. This number is still 1,000. Kevin, that's not much of a hint. And I'll give you a hint. This one starts with 1 point. That's not much of a hint either. I'll give you another hint. This one starts with a 2. There. Those are all the hints I'm going to give you. Go. Line. Buddy. A teacher in Maine, during a test, took his phone, put it face down next to a student, had it on silent, no vibrate, no sound. Just put it there next to a student taking a test. The student did much worse on the test than if the phone wasn't there. Isn't that interesting? We are so attuned to our phones that we can't even concentrate when it's not even our stinking phone. Isn't that amazing when you think about it? I can tell you this. I don't pay attention to my phone. It's a distraction of epic proportions when I'm doing something important like teaching or fishing. I don't have a clue how to do it. Raise your hand. I got the right answer. Raise your hand. Okay.
How about is there a middle?
Is there a middle ground? I kind of think I know what I'm doing.
Because I think.
Okay, what do you think?
I don't want to say because I think I might be wrong too.
Oh, okay, and I would just crucify you if you'd be wrong, because I always do when people make mistakes. I just don't let them forget them ever. Like Mason Crosby, for example. I was half expecting him at the end of the game to pooch the kick. I really was.
He's not that bad. He said one bad game.
2, because he also didn't win the Vikings game.
Well, that keep it over there, so.
Well, they fired their guy. What are you going to say? If I said this is a 4, would you tell me why it's a 4?
Because in 1 year there's 12 months, in 2 years there's 24.
Everybody okay with that part?
I already got it wrong.
And then isn't that 1.025?
Close.
0.25.
1.005.
Yeah, way off. Way off.
Yeah.
Why is it 1.005? Because 6% divided by 12
It's half of a percent.
is a 0.5%. So here's the clue when you see compounding. Multiply this number by 12 and divide this number by 12. Okay? Does that make sense? Now, on your credit card bill, it will say interest rate is 1.5% per period. We don't care what it is per period. What would it be per year? Well, first of all, a credit card bill comes every month. So what are we going to do to the 1.5%?
Multiplied by 12.
And we get, I don't know, Kevin, you want me to do it? Or you want me to do it now? Or you want me to do it now on my calculator? Yes, I do. Start pressing buttons.
Oh my God.
Well, this math is not a spectator sport. It's like participatory.
I'm still trying to figure out what I was writing down there, Kev.
What are you going to do with the 1.5?
Multiplied by 12.
And you get
18.
18%. Does that make sense, everybody? All right. Here we go. Page 140. Over the 2-year period, if the annual rate is 6%, what is the monthly interest rate? 0.5%. Over the 2-year period, how many times will the bank pay interest to you? 24. So you could go through these choices. For 1 month, our calculation would be 1,000 times 1.005 to the first. Our second, for 2 months, it would be $1,000 times, I should do it so that you can see both at the same time. 1.005 to the second. Is the next one 3 months?
Yep.
1.005 to the third. The next one is 6 months. Got it? Write a general formula that can be used to calculate the value of any CD. So let's go through it and let's see if we can come up with a good formula. Any CD. M, where M is going to be the maturity value. Equals, what's our second variable going to be?
Principal.
P, which stands for principal. Times 1 plus, and we're going to need a fraction here. The rate divided by the compoundings. R equals, lowercase r, sorry. R equals the rate as a decimal. C equals the number of compoundings per year. To the Where's my purple pen?
Didn't it die yesterday?
No, I got another one though, someplace. Huh. And I brought it home yesterday. Got a bunch of them in my pockets that I brought home, and I didn't notice until I got home that I had them there. Okay. Not that you care. But it's really important to me. To the time times the compounding. Note, these two variables are the same. So whatever you divide the rate by, you multiply the time by. And so T is the time in years. I should have done C in a different color because it works with both the rate and the time. Okay, so let's make a little table to help us practice with that. So let's say we had the R over C and we had the T times C. And let's say we did let's say 8% quarterly. So what would this fraction be? 0.08 over 8% quarterly for 5 years. 0.08 over how many quarterlies are there in a year? 4. What do you get when you take 0.08 divided by 4? 0.02. What would this be here? 5 times 4. How many quarterlies are there in 5 years? 20. Okay? I'm going to do some more examples. 9% monthly for 6 years. Let's say 5% semi-annually for 7 years. And here's a tough one. 3.2% daily for 4.3 years. Go. Work with the people sitting at your table. I'll walk around and help you if you need help. But I think everybody should be able to do those. Know what you're doing? Okay. What does the word quarterly meant 4. The next one is 9% monthly for 6 years. You can't read that?
Not really.
Okay, sorry about that. 6 years, 9% monthly. So what are we going to do with the 9%?
I think I know what I'm doing.
What did you get, Brandon, so that you can explain it to
For the first one.
8% is what we did together, yes.
You get 9%.
And what did you get for an answer?
Hey, so I thought it was only 2.
Well, I thought we were actually
I was happy.
We are actually answering them.
Oh.
Yeah, we are actually putting in the answers in the blank. So he says that first one is 0.0075
Sorry.
because he took 9% divided by 12. Okay?
Is that 5% the third one?
Third one is 5% for 7 years, semi-annually. The last one is a tough one, 3.2% daily for 4.3 years. You know what you're doing, Madeline?
No, I don't.
Well, let's do this one right here. How many semi-annuals are there in a year?
2.
2 of them. So what are we going to do with the 5%?
We divide it by 0.5, or I mean multiply by 0.5.
Or divided by 2.
Okay.
So we take 0.05 divided by 2, and what did you get for an answer? Okay,
Is that for the fraction right there before
Right.
we do anything?
so it'd be
Because the percent
0.05
never changes.
divided by 2. What's that?
The percent on top never changes.
It does actually. Here it's 8%, here it's 9%, here it's 5%, here it's 3.2%.
Well, yeah, but like when we write this out, it's not different, right? It's like this never changes.
Right, that's always the rate.
Okay.
Did you get the semi-annually? What did you have?
It would be like
2.5%. You agree, Madeline? That makes sense. 5% for half a year is 2.5%. Because half of 5 is 2.5.
It's
So your semi-annually would be 0.025. Would you agree that's 2.5%?
Yes.
How many semi-annuals are there in 7 years? So you would write 7 times 2 equals 14. Got it? Felicia, you know what you're doing?
Yep.
Lexus?
Yeah.
Eric?
Yep.
Eric here. Gavin? Sam's got them all filled in. Why don't you put your paper up on the screen there, Sam, so we can make sure that everybody gets them. Well, you can check your work here in a second because Sam's got answers. Well, if you notice, it says just take the rate times the compoundings. So it would be 1569.5. Can you raise a number to the 1569.5? Yeah, you can. Actually, I think what they would do on that one is they would say, if you take the 0.3 times 365, how many days is that? Do it on your calculator. 0.3 times 365. Oh. Yeah, so they would say 1569.5 days. Okay, if you took 0.3 of a year times 365, how many days is that? So 109 days or 110 days. Obviously, if they tell you that they're going to pay interest daily, I think they would say that'll be 109 days because you don't get credit for the 110th day until you've left it there the whole day. Everybody good with those numbers that Sam put up? Do they make sense to everybody? Savannah, that's what you got? Madeline, you okay there?
Yep.
All right. Thanks, Eric. Sam. All right. Next. If compounding is done more often, what happens to the amount that you get? In other words, let's say you start with 12% annually. Then you take it to 12% semi-annually. Then you take it to 12% quarterly. Then you take it to 12% monthly, 12% daily. What do you see happening to the amount of interest that you get? Well, let's do the math in Desmos and let's see what we end up with. So give me an amount of money. $10,000. Oh, let's see. Let's do it as a table. That'll be better. So add a table. And this number is going to be our compoundings. So X will be our compoundings. So this will be $10,000 times 1 plus our fraction, which is going to be, let's say, 12%. Divided by our compoundings to the number of years. Let's do it for 4 years. Times the number of compoundings, which is x1. I have to change this compoundings to x1 here. Okay, so now, if we compound it once a year, we end up with $15,000 over the course of 2 years. If we compound it semi-annually, you notice the amount of money went up by $200. So we got $200 more interest by compounding it semi-annually. If we compound it quarterly, notice we got even more money, but this time we didn't get as much as we did the previous time when we doubled it. If we compound it monthly, we get more money. If we compound it daily, we get more money. If we compound it secondly, what would we have to do? 365 times how many hours in a day? 24 times how many seconds in an hour? 3,600. So if we compounded it secondly, notice we would only end up with $1 more than if we compounded it daily. So is it worth it to compound it? They call it instantaneous interest. Not really. But it makes it sound good to your customers. We compound to the nearest second. So your money will grow bigger at our bank than those sad sacks that compounded daily. We compound it every second. I don't know. That's what they say. Got it? Okay, so in answer to this question, the more often you compound it, the bigger your interest gets. So you might want to write that down there for page 141. Questions? Page 142. Some stuff goes up in value, some stuff goes down in value. There's another place besides depreciation in which stuff decreases. Radioactivity is one of those things. Does anybody know the word that goes with how they describe radioactivity decreasing?
Half-life.
Very good. Half-life. In other words, how long it takes until you have half the value left. Well, if you look at this, the value of the car starts out at $26,000. After 5 years, it's about down to $13,000. So its half-life of this car is about 5 years. Okay? Does anybody own a really, really old car? What do you own?
2000 Toyota Camry.
Can anybody beat a 2000? Oh yeah, you think that's old? I own a. Nobody can beat a 2000? Are you guys rich or something that you drive these big, expensive, brand new cars?
I used to drive a 1999 Ford Ranger.
Okay. So we've got a 2000 Camry. All right. Does anybody own a really, really new car? What do you own?
A 2015 Kia Forte.
Can anybody beat a 2015 Kia Forte? Okay. So 2015 is where we are versus a 2000. Would you agree they have a certain value right now? Okay. Next year, whose car will have decreased in value more? Why would Savannah's car decrease more? Because it's newer, right? If you are looking at in the ads, in the paper for a car, and you see a 2000 or you see a 1999, what are you going to say? Yeah, whatever. Okay? What are you going to look for instead of how old it is at that point? How many miles it has on it? And what kind of a car it is, right? If you had a 2000 Camry or a 2000 Forte, which there was no Kia Forte in 2000, which do you think would be worth more? Does Kia still have the lifetime warranty? Or is it 100,000 miles? You don't know.
I think it's a lifetime warranty. I don't know. I got it from a dealership in Minnesota, to be totally honest with you.
Oh, and so you think you got ripped off? Is that what you're saying?
No, I just don't know what else.
You just don't know.
I just don't know.
Does anybody know anything about Kias? Don't they have a lifetime warranty, or is it 100,000 miles? Nobody knows. Isn't that an important consideration? Because if you had a Kia Forte from 2000 with a lifetime warranty, that'd be a good thing to own, right? Now, when they say lifetime warranty, it's not on things like it rusted out. That's one of those, yeah, too bad for you. It's probably something like powertrain, which would be like the engine giving out or the gearbox giving out. Is it an automatic? Is yours an automatic? Okay. I owned a 1991 Camry that I bought from a professor down at the university. Got into it and I said, smells like pot in here. And so the entire time I owned it, I was like, oh, please, Lord, don't let me get stopped by the cops, because they will smell my car and they will say, step out of the vehicle, young man. So, yeah, my son said the same thing. Dad, I just am afraid to speed with that car because I'm going to get stopped and then they're going to think I was smoking weed. And it never left. Anyway, what's that?
So there might have been some hidden in there. You could get rid of it.
Well, there could have been, but it smelled like burned pot rather than unburned pot. I don't know. It's hard to say. So, for example, new automobiles typically lose between 15 and 20% of their value each year for the first few years after manufacture. Now, it says compare depreciation of car with interest accrued on a certificate of deposit. So let's draw a picture of those two things. So here we've got depreciation. Everybody agree? The car starts out as certain value and it goes down over the course of time. What one rule is probably going to be true about as you get farther and farther out here? It probably will never be worth less than 0. Right? Because worst case scenario, what can you always do to your car? Sell it for scrap, right? Take it over to Phoenix Steel and they'll take their big magnet on it, suck it up and drop it into the hopper and chop it into small little pieces. That's depreciation. Let's talk about interest on a CD. What's going to happen there? It's going to go up this way, right? Now, we don't care about this part times this part. We don't care what those numbers are. We only care that in depreciation, something is going to be true about this compared to something being true about this. What is true about depreciation versus interest? Do you remember our... Oh, I'm sorry, that's not the... I have the wrong part. This isn't what we pay attention to because that's time. That's time in every case. We care about this part here and this part here. Those two parts we do care about. What's true about this number in a CD?
It's positive.
It's not just positive, because this is also positive. The number is always going to be positive, and that's because if you raise a negative number to a power, think about it. Negative 5 to the second, what do you get? Positive 25. Negative 5 to the third, what do you get? So if you try on your calculator to make this variable be this variable be negative, you can't get a function to work with it because it keeps going from positive to negative. And what happens if it's negative 2.3? Is it going to be positive or negative? Heck if I know, right? Because we only know what happens at the even spots. We don't know what happens at the fractions. So that's not going to be, they're both going to be positive, but there's something else that's going to be true.
CD is going to be greater than 1.
This is 1 plus a certain value, correct? Whereas this one up here is going to be 1 minus a certain value. Okay? And the depreciation that they talk about here is 20% or 15%. So what is our number that we're going to raise to the power of time? In this case, it'll be 0.85 to the power. And in this case, it would be 0.80 to the power. Got it? Remember, when you have a decrease, you use that complement. Got it? So if we look here at our problem, it says, compare the... we did that one. So, you start with a new $26,000 car. What is its value going to be in our table here? $26,000, right? So when it's new, it's worth $26,000. Now, what's interesting about it is that depreciation doesn't happen in this smooth, curve-fitting way. The second you drive your brand new vehicle off the lot, it just lost $2,000 in value, $3,000 in value, I don't know, a certain amount. Because right now, as soon as you drive it off the lot, you can't sell it as a new vehicle. You have to sell it as a used vehicle. Okay? And it's going to cost considerably less because nobody wants to own a used car if you can buy a new car for the exact same price, right? That doesn't make sense. So you're going to pay for that used car less than you would pay for the brand new one. But let's assume that the calculation is what they give us here. So after 1 year, what will our calculation be? 26,000 times 0.85 to the first. Now, if you notice, Brandon didn't say times 0.85 to the first. He said times 0.85, right? Okay, so I am 59 to the first years old. I did that calculation in my head. Could you calculate your age in powers? What would you get? 19 to the first, okay? And what did you get for a value after 1 year?
22,100.
Okay, so you guys are going to do 2 years. You guys are going to do 5 years. And you guys are going to do T years. What? How can I do T years, Kevin? I don't know. See if you can figure it out, okay? Anybody have some answers for me?
For 2 years? Yeah.
Say it.
18,785.
Do you have the cents?
Can't remember no sense.
There were no cents? Okay. 5 years.
11,536.33.
T years. 26,000 times 0.85 to the T. Now you would say, well, Kevin, that's exactly what the formula is, correct? But that formula is really, really powerful because now we can use that formula to figure out for any time. And the one that they give us right below the table is how many years? 10 years. So what do you get for 10 years?
$5,118.73.
$5,118.73. Now that's assuming that it's an average car. I'll give you an example of an unaverage car. Oh, I should look up the Blue Book value. You didn't get what?
Maybe I'm doing this wrong.
Okay, so I'll do it on my calculator. 26,000. Are you doing it on your graphing calculator?
Yeah.
Okay, so 26,000. Are you pressing it? Or so far so good?
Mm-hmm.
Times 0.85 to the key 10th. And you did not get 5,000? You did not get that?
Oh, I typed it in wrong. That's why.
Oh, okay.
Why is it to the 10th again? I missed that.
Because it's right here, it says worth in 10 years. Do you see that underneath for number 4?
Yep, got it. Thank you.
You're welcome. So, anyway, I was going to say an atypical car. So let's say Blue Book value of 2002 Tundra. I suppose this is the only place we can do it. I hate that because make, category, pickup. Where is it? Am I in cars? Trucks. I'm not going to do Kelley Blue Book. That's way too complicated. Here, NADA guide. Let's try that. Here we go. It's a 4-wheel drive, Access Cab 4-wheel drive. Enter your zip code. Why does that matter? 54701. If it asks for my name and address, I'm going to be upset. So, oh my word. Okay, so that's what it says. Clean trade-in. Oh, I should go down to options because it's possible that they've got price plus options. Guy offered me $16,000 for my pickup, and that's the pickup right there.
You didn't take it?
No, because I wanted to go fishing. And if I sell that pickup, I got to buy another one. And if I got $16,000 for this one, I would have to pay $56,000. How much does a new pickup cost? Right, that range, $56,000. Okay, unless you guys want to contribute to the Kevin Hulke pickup fund, it ain't gonna happen. So
I'll start GoFundMe.
a GoFundMe, yeah. Okay, so the value of a vehicle depends on how many miles it has, and the deal was not made because, in my mind, my pickup was worth more than money, because I would need to spend more to make it pay off. Here we go. Next one. Oops, that's tomorrow. Let's see. So here's what's happening. We are going to work on the review on Thursday. I was talking to one of you guys yesterday, and the student says, oh, so I have to sign up for the next class? Yes, indeed you do. If you are going to take college algebra starting on Monday, you need to sign up for college algebra in your SIS. Okay? Because we're going to have a different book, and we've got a different code. Lauren, do you have that code written down someplace that you can tell them what it is? Because I don't remember. Anybody that wants, you can get in for your 14 days for free. The code is Hulke something.
Yeah. That's Hulke's 37292.
37292. Okay? Hey, and I urge you to take it right away. Don't let the math get old. If you're going to take it ever, take it right away. Because math gets old and stale. And then you can't sell it as fresh bread. You have to sell it as day-old bread. They tore down the day-old bread store over on Brackett Avenue, just ripped that thing right out of the ground.
I wouldn't sell math as day-old bread. I'd sell it as cow.
As cow manure, which is very worthwhile. Cow manure is one of the most expensive commodities in the world. They use it for fertilizer. So there you go.
Yeah.
One man's hoop is another man's treasure.
Where do you go to?
You know what? Go like straight. Go and then go to your right and go back. There's no to go. Oh, no, it's just kind of like this.
My math lab?
Yeah, what's that, Sam?
With the the quizzes that we do every week.
Yeah.
Is there a certain percentage we need to get the points for that week, or
No.
is it just based on what I score? That's how many points I get.
Correct.
Got it. So if I got
If you got a 90 and there were 35 mastery points that week, you'd take 0.9 times 35, and that's how many mastery points you get.
Okay, so it might be worth redoing.
No, not really, because there's only a total of, I think, 200 or so mastery points, whereas each test is worth 350. So you'd be better off redoing your test. How are you?
Split it up for Mario and just grab it for a while.
Well, if I get a chance to do it, I'll start from the last page, work my way backwards.
I don't have anything to do for today, is it?
Not sure.
I know.
Our journals are due on Thursday, so, and I think our quote is due next week.
Yeah, Tuesday.
So,
Wait, that's too nice.
I think there's just someone that has like a station on me. Quotes it.
Don't get to drop one crazy cool verse. Must